In this video we're going to be finding the mean, the variance and the cumulative distribution function of continuous uniform distributions. So let's get straight to it. Let's start finding the mean, or show you the formula for finding the mean of a continuous uniform distribution. Now all of these formulas that I'm about to show you are in the formula booklet in the exam, so they're very easy to remember, and in fact they're very easy to apply as well. So I'm just going to set up a random variable. So we have 1 over b minus a when x is between a and b, and the graph of that is going to look something like this. Obviously it's going to be rectangular shaped, so it's just going to be a straight line between a and b, and it's 0 otherwise at a height of 1 over b minus a. Now for the expectation of x, or the mean, all you need to do is apply the formula a plus b over 2. Now remember, with PDFs, if the graph is symmetrical, it's the central point of the PDF that's the mean, and you can see that working here as well. So this value here that I've done in orange in the middle would be the average of a plus b divided by 2. Moving on to the variance, there's quite a large proof for finding the variance. However, I'm not going to show you that in this video. All I'm going to show you is the general formula, and you should note this down for any continuous uniform distribution. So for the variance of x, the way you find this is by doing b minus a squared and then divide by 12. So again, very simple. It's given in the formula booklet. And for the final one, for the cumulative distribution function, so if we had to find the cumulative distribution function for this, what we would have is it's 0 when x is less than a, it's x minus a over b minus a, and that's when x is between a and b, and then it's 1 when x is greater than b. So I'm just going to show you a quick example of how to apply this one. So I've got a question here. I've been asked to find the cumulative distribution function, capital Fx, of this continuous random variable. So I'm just going to apply the formula. So in my brace I'm going to say it's 0 when x is less than a, and in this case a is minus 2, so when x is less than minus 2 it's 0. X minus minus 2 is plus 2 over b minus a, so 7 minus minus 2 is 9. So that's the function when x is between a and b. So that's when x is between minus 2 and 7. And then it's 1 when x is greater than 7. So this is very simple, and now I'm just going to quickly show you how to apply the mean and variance formulas to an exam question that I've prepared. So if we go to my exam question, it says the time in minutes that Elaine takes to check out at her local supermarket follows a continuous uniform distribution defined over the interval 3 to 9. Find Elaine's expected checkout time. So Let's start off by sketching this. So we know that it's between 3 and 9. It's a uniform distribution. And this height here is going to be, well, the gap between 3 and 9 is 6. So it's going to be 1 over 6 as our height. We didn't really need to do that in order to find the mean. But it's always good to sketch the information that you've got. So the expectation of x is a plus b over 2. So that's 3 plus 9 over 2, which is 6. And 6 is the midpoint of this PDF. So that's why it's the expectation of x. Now let's look at the variance. So if you remember, the variance is b minus a squared over 12. So applying that to this formula, we're going to have 9 minus 3 squared over 12, which is 6 squared over 12, which is 36 over 12, which is 3. For part C, I'm going to finish off this exam question, even though it's not totally applicable, because part D can be quite challenging for some people because it requires some S1 knowledge using the rules of where you're given something that's already happened. But let's just focus on part C first. So for part C, we're asked to find the probability that Elaine will take more than 7 minutes to check out. So we're finding the area of more than 7 minutes. So that's this section here. And so the height of this rectangle that we've got is a sixth. The length is 2, so that's 2 times a sixth, which is 2/6. And so the probability that x is greater than 7 is a third. So now moving on to part D, I'm going to give myself a little bit more space here. It says, given that Elaine has already spent 4 minutes at the checkout, find the probability she will take a total of less than 6 minutes to check out. So we're finding the probability that she takes less than 6 minutes to check out, given that she has been already queuing for at least 4 minutes. So the way that I like to try and solve these questions is by using a Venn diagram. So we know that she's taken more than 4 minutes, but she must also take less than 6 minutes. So I've shown that with these two circles forming a Venn diagram. These are all the scenarios where x is greater than 4, and these are all the scenarios where x is less than 6. Obviously we've got some overlap, but not all the overlap. What we want to find is the probability of this area here, where it's less than 6 but greater than 4. And we can see that the probability of that happening is the probability that x is between 4 and 6 divided by the probability that x is greater than 4. You can basically look at it as a fraction or a portion of this entire circle here. So of all the scenarios where x is greater than 4, we just want this portion where x is between 4 and 6. So it's that portion where it's between 4 and 6 out of all of those scenarios. So in order to work this out, we need to have a sketch of the graph. X is between, or the distribution is between 3 and 9, with a height of a sixth. And so we need to find the probability that x is between 4 and 6. So that'll be this bit between 4 and 6. So the probability that x is between 4 and 6 is, well, the length of that rectangle is 2, the height is a sixth, so 2 over 6 is a third. And then the denominator of the fraction is that x is greater than 4, so if we find that area there, which I'm going to colour in a different colour, that's a length here of 5 and the height is a sixth, so the probability that x is greater than 4 is 5 times a sixth, which is 5 over 6. So if we turn this into a fraction, 1 over 3 divided by 5 over 6, if you pop that into your calculator, you should get your final answer as 2/5.